Okay, so multiple choice. Put your capital letter, answer choice in the blank to the left of the number. Okay, what type of letter are we putting? Capital. Ooh, man, I'd hate to miss it by putting a lowercase letter there. Good to know. Find the range of this function. Range, is that the x values or the y values? Y values. So it would be helpful to have the what of this graph? The sketch of the graph, yeah. Or the graph of the function, maybe that's a better way to, yeah. The what of the graph, the sketch of the graph. Okay, it's Friday. Did you realize that? So is it in standard transformation form? Almost. In the exponent, which is where we're inside the function, I would factor out the 5, and I'd be left with x what? Plus 4/5 minus 3. Okay, now the horizontal shift for this function is not a big deal, is it? Okay, what's important for the range for the e function is the thing that'll move the horizontal asymptote, which is the what? What's the only transformation that moves a horizontal asymptote? A vertical shift, good. And then any type of reflection that we have is going to change the orientation. The most important one here is if we reflect it across the x-axis, which is if we have a negative in the front. And we don't. Since we only have a positive 3 that takes your parent function, which I'll sketch in light blue here, it's going to vertically stretch it by a factor of 3, and that's it. Then the 5 is going to horizontally compress it by a factor of 5, yeah? So this is still our final shape of the graph, kind of important. And now all we're going to do is do what? Move it down 3, right? Down 3, down 3. So here's negative 3, la, 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 la. And the graph is going to have the same shape above there. What's the range? Negative 3 is the lower bound. Do we actually hit it? No. And then it's everything above to infinity. All right, so now we look for that answer. Please be there, please be there. Is it there? Yeah, so the answer is A, B, C, D. E? E. There you go. Everything entirely above the horizontal asymptote. So sketching the graph helped, right, answer the question. And it was not, didn't take very long. Now, of course, if you didn't have the right parent function identified, it might be a little more difficult. All right, questions on number 1. Number 2, by the way, when you retest on Monday morning, I think I'm going to give you something eerily similar to this, and you'll just have to generate the graph. Okay, eerily similar. I mean, you're going to look at it and think that it was like last Friday, like Halloween, and we were reading stories. It's going to be that eerily similar. Ooh, like a doppelganger problem. Well, why do I say that? If you know how to do this problem, and you have to retest on Monday, you should know how to do Monday's problem, right? Not if you're retesting, but when you retest, right? Those of you out there who know who you are, right? Okay, good. Number 2, you got f is that and g is that. What's the domain of fog of x? Fog of x is another way to say f of g of x. So what's the inside function, f or g? G. We're going to take g and we're going to plug it into f. Very similar to the warm-up. So I'll start with f, not with a highlighter though. We get f of g of x should equal 2 over 2 blob minus 1. So notice, what did I do? In the f function where I had an x, what did I do first? Parentheses. We've had that conversation more than 10 times. And then I'm going to plug that in for the parentheses, and I get that. Yay, go me. Now we're looking for the domain. Should we simplify and then find the domain, or find the domain then simplify? Find the domain. That's right, because sometimes when you simplify, you change the domain. So now I know I have a radical. So I know that my radicand, x minus 1, has to be greater than or equal to 0. Yes, yes? That means x has to be greater than or equal to 1. I didn't have to change or flip the inequality. So that's the demands of the radicand. Now I got the entire denominator. And the entire denominator can't be what? Can't be 0. We can solve that like an equation, right? So do 2 square root of x minus 1 can equal 1. Divide by 2. Square both sides now. And remember, when you square both sides, 1/2 times 1/2 is 1/4. You have to what with your answer? Check for extraneous solutions. When you add 1 to both sides, 1 plus 1/4 is 1 1/4, also known as 5/4. Now we're going to check. We're going to check. Yeah, can equal. Good. So if you plug 5/4 back in, what's 5/4 minus 1? 1/4. What's the square root of 1/4? 1/2. What's 1/2 times 2? 1. What's 1 minus 1? 0. Ha! Nice try, 5/4. We caught you. We caught you. So the domain is everything greater than 1 except 5/4. Do we have to exclude 5/4? Is it greater than or equal to 1? Yeah. So notice your answer choices are all written in interval notation. So 1 is an upper or a lower bound. If we want everything greater than or equal to 1. It's a lower bound. So we're going to start at 1, including 1, and then when we get to 5/4, we have to gingerly step over it. Okay? Make sure you're stepping gingerly. And then, once we get past 5/4, we can cruise to what? Infinity. Yeah, now we can match it up. Is that answer there? I sure hope so. If not, I'm going to raise my hand and tell the teacher that there's an error on the test, because I know that's right. Is it there? Yeah, it's also E. So in no particular order, the answers to the first two were E and E. A. Dang it. Dang it. Dang it. I hate when I do that. I hate when I do that. I get the right answer. It's right there. All the work is right there. And then I get the wrong answer. I look at the wrong answer. I get excited at the end. My eyes start crossing. They all look the same, and I choose the wrong answer. So I go up to the teacher, and I'm like, I have the right answer here, but I put E. Can I get credit? What will I say? No. That's unfortunate. But that's where the free response comes in, right? Because on the free response, you have that and you walk away. Of course, if that were a free response, you would have to have this right here to get credit. But just make sure that you're picking out the right answer from the lineup. It's a step you don't want to take for granted. Oh, okay. I'm glad I learned that lesson. All right, moving forward. What's the domain of this function? Well, you could sketch the graph of this, right? And it would be no big deal. But here's another way to do it. We can only take logs of what types of numbers? Positives, right? We can only take the log of positive numbers. So if you graph it, that's fine. But if you noticed, if you take your what do we call the thing we're taking the log of? Argument. If you know, just like with the radical, that thing right there in the end better be greater than 0, so when we take the log of it, it's a positive number, you can actually work it out algebraically. Is this a linear inequality? Yeah. Can we solve it algebraically? Yes. So negative 4/5 x has to be greater than negative 3/4. I'm going to multiply both sides by negative 5/4. So I'll get negative 3/4 times negative 5/4. It divides out on the left, and I get that. And I end up with x is greater than 15/16. But of course, what am I in the habit of always doing? Checking. I always check. So I'm going to pick a number now bigger than 15/16, like 16/16, a.k.a. 1. I'm claiming 1 works, right? Let's try it. If I plug in a 1, I get 3/4 minus 4/5. Oh, what is 3/4 minus 4/5? Well, that's going to be 15 minus 16, which is negative 1/20. I end up with a negative number. Holy moly, smokers. What happens? I chose a number that I thought was going to work, and it didn't. Oh, yes, I forgot to do what? Flip the inequality. Do you think anyone has ever done that? Yes. Okay. It's a good thing that I'm in the habit of checking my work so that I can catch careless mistakes, because I am a pro at careless mistakes. I get excited near the end of the problem. Math excites me. It gets my amygdala going. Okay. Now, is that answer there? Oh my gosh, they all look the same. Look, like we're in a house of mirrors. Da-da. Which one? Is that it, eh? Yes. Yes, it is. Okay, so now we got EAA. Any questions on that one? Could you have graphed it also? Sure, let's see what that would look like, because you would have to, and I'm just going to focus on the inside. You would have to put your x term first. And then, of course, you would factor out a what from the inside? A negative 4/5. And we're left with x. I know the sign changes, so here's what I do. I go with 3/4, and I'm dividing out a 4/5. I know the sign's going to change. Stay, change, flip. It's kind of like you're telling You're at a dog show and you're telling your dog what to do. Stay, change, flip. Oh, you're going to win the dog show if your dog can do all that. Especially if no one else enters. 15/16. So, it doesn't really matter what happens on the outside. Moving the natural log function up and down 3, north and south, doesn't affect it. Compressing it by a factor of 3/2 doesn't affect it. For the natural log function, the flip across the what axis is that? Y-axis, and the shift to the right are super important, because when I flip that across the Y-axis, it looks like that, and then I'm going to pick it up and move it to the right 15/16, and so now I have a vertical asymptote right here at x equals 15/16, and now my domain says it's everything to the what of 15/16 left. So does that work also? Heck yes. But an FYI, if you ever have a log function, and we're going to study this in greater detail later, all you have to do to find the domain is take your argument and say that it's what? Strictly greater than 0. You can do it without graphing it, because you can only take logs of what types of numbers? Positives. Okay. Number 4, the range of this function. Oh boy, I love absolute value transformations. I love them. So what I need to do first is get the graph of f of x, and then I can do this transformation to it. Yeah? Is this in standard transformation form? Yes, you are welcome. You're welcome. So my original function looks like that. The negative reflects it across the x-axis, and the 3 vertically stretches it by a factor of 3. Okay, so that's my final shape. Oops. That's my final shape right there. It opens down. What does the -4 do to it? Shifts it down 4. So now if I move it down 4, that's like moving the x-axis up 4. Pretty sneaky. So here's y equals -4. All right, so now that I have that, I want to apply this transformation to it. And remember what that does? It takes all of your y values and makes them positive. They're the same magnitude, but now they're positive. So remember the graphical way to do that was to take all the y values and reflect them across what? The x-axis. Okay, so when I do that, my horizontal asymptote at -4 jumps up to where? +4. And then everything else goes whoop, and now it goes like this. Whoop, and there's what my final graph looks like of g of x. What's the range? Everything greater than 4. So 4 to infinity. Including 4 or not including 4? Not including 4. Okay, so there you go. Questions on that one? Hey, while we're here, what would G look like if I took the f of the absolute value of x, the input instead of the output? Yeah, very good. Everything that's positive x stays the same, and then we would reflect that across the y-axis to get this, and it would look kind of like an upside-down V-neck. What would the range be now? It would be everything below the what intercept? The y-intercept. Let's find what the y-intercept would be. F of 0 is -3. What's e to the 0? E to the 0 is 1. So I get that, and I get -7. So if that's where this was, at -7, now my range of the purple nurple graph would be everything below -7. So it would be -infinity up to -7, inclusive or non-inclusive? Inclusive, yeah. So both of those transformations are awesome because they give quite different results. All right, number 5. What is the range of G inverse? I'm not going to find G inverse and look for the range because I know that the range of G inverse is the what of G? Domain. So let's find the domain of G, which is a lot easier to do. I can't divide by 0. So 3x minus 7 can't be 0, which means 3x can't be 7, which means x can't be 7/3. So again, in interval notation, it's -infinity to 7/3, union 7/3 to infinity, and that's answer choice B. Wow. So we have E, AA, and then BB. Wow. Lots of A's and B's and one E so far. Okay, questions on that? That's the easiest way to do it. Hey, what if I asked you for the domain of G inverse? Could we do that? The domain of G inverse is equal to the range of G. And remember how we find the range? We know this is a transformation of 1 over x. So all we have to do is look at the leading coefficient over the leading coefficient. That's where the what asymptote's going to be? Horizontal. So it's going to be everything but that y value, which is what? Negative 5/3. Is that an answer choice? Everything but negative 5/3? Yeah. Okay. Cool beans. Cool beans. Oh, I lost my answer here. What was the answer? B? Yeah, okay, cool. Number 6. If h is that, find two functions f and g such that h is equal to f of g. How would you do this problem? This one's probably best to do by just plain old plugging them in, trial and error. So g is going to be my inside function. All right, let's try it out. I want to get this as an answer. Let's try out a. If I try out a, I'm going to get my new function h to be f of g. So it's 5 plus e, 3 parentheses. And in place of x, I'm putting x minus 1. Now, if I simplify that, I get h equals 5 plus e to the 3x minus 3 when I distribute. Is that equal to e to the 3x minus 1? No. Sorry, A. You're close, but you don't get the cigar. Okay, you shouldn't be smoking anyway. So I would probably have to give you another prize anyway. Close, but no. Close, but no pat on the back. It's a lot healthier. Depending on how hard you pat people. I've been known to pat people too hard. All right, let's try B. I got h equals, 5 plus e, 3 to the blob again, right? And now I'm plugging in for the blob g, which is x minus a third. If I distribute in the exponent, I get 5 plus e, 3x, and then minus 3 times a third is 1. Comparing that, is that what I wanted? Presto magic. Way to go, B. Way to go. Good job. The answer is B. That was actually a pat on the front, huh? To pat it on the back, I'd have to go into Mrs. Smith's room. I don't know if I want to interrupt her class. Questions on that? Trial and error. Trial and error. Are parentheses important? Very important, right? They're your best friends in a math class. It's better to have them and not need them than to need them and not have them. Yeah. All right, number 7. If G is that and H is that and J is that, whoa, I got to back up. That's a lot of stuff. If G is that, got it, H is that, linear, and J of X is also linear, what is the domain of G over H of J of X? All right, I guess the first thing is to set up P of X. It's G of X, which is 3 times 7 minus X, all over H of J. H of J is going to be 3 plus 3 parentheses, and into the parentheses I'm plugging J, which is 5 minus 2X. Our first 2 tests of the year had free response questions very similar to this, right? But now it's a multiple choice question. All right, I'm going to go ahead and I guess we have to find the domain before we simplify, yeah? Okay, so I have a square root in the top, so I know that 7 minus x has to be greater than or equal to 0. That means negative x has to be greater than or equal to negative 7. I'm no fool. I learned from my mistakes. When I multiply both sides by negative 1 now, I'm going to flip the inequality and I get positive 7. And very quickly I check. Pick a number like 6. Does 6 work? 7 minus 6 is positive. It works. So that's the demand of the numerator, the radical. Now the denominator, I know 3 plus 3 parentheses 5 minus 2x can't be what? 0. Now that's linear. So to solve that, you can expand it out. 3 plus 15 minus 6x can't equal 0. So you get 18 minus 6x can't be 0. You get 18 can't be 6x. And you get by divided by 3, right? 3 can't be x, which means x can't be 3. Now we only have to exclude 3 if it's less than or equal to 7, is it? Yes. So notice the answers are in interval notation again. Wow. So negative infinity up to 3, Once again, gingerly stepping over 3, cruising all the way up to 7, and then including or not including? Including. Is that there? It better be. I'm going to find it this time. There it is. The answer is D. Yeah. So far, so good? All right. H. Oh, my gosh, there's a lot of words here. I have to read them. In the function g equals 4 square root of x, the 4 vertically stretches the graph square root of x by a factor of 4. If this were a true or false question, I would put true. Right? In fact, I'm going to put true. I think that's a true statement, right? The 4 in the front, it's an a value. It's going to vertically stretch by a factor of 4. True. True. This is equivalent to what other transformation of f to produce the graph? Okay. I guess it's not a true or false question. Everything talks about horizontal stretch or horizontal compression. What letter in the standard transformation form is responsible for the horizontal dilations? A, B, C, or D? B. B. So I need to somehow take g of x equals 4 square root of x and write it equivalently as the square root of something times x. And every function's unique. So how do I get a 4 back under the square root? Well, think about it this way. I need to have a number here so that when I take the square root of it, I get 4. The square root of what is 4? 16. So is that equivalent now? Yeah, it is. Okay. And now that it's a 16, is that going to be a horizontal stretch by a factor of 16? No, it's the opposite of what it appears. It's going to be a horizontal compression by a factor of 16. And is that an answer choice? Yeah, answer choice D. This one was a little bit easier than the one that was on, I think, the practice test or something like that. Because it was like 5 over x. And that was a same as 5 as 1 over x. That was going to be a vertical stretch by a factor of 5. But in order to get a 5 from the numerator into the denominator, you have to put the reciprocal. So 5 over x is the same as 1 over 1/5 x. That would be equivalent to a horizontal what? Stretch by a factor of 5. So we didn't have that one there. Anyway, those are the answer choices that are correct. Any questions on those before we gallop to the free response? Here we are. We are unicorns, so we gallop. Oh, if I put okay and then a check, that means you have a wrong answer somewhere before that, but you use your wrong answer correctly to answer that question. So you have the wrong answer, but I gave you credit based upon your previous wrong answer. Does that make sense? If I put not, then that means, not means notation. I got real lazy. You have one check for the notation, so I started abbreviating notation not. So if you see not check, that means you did get a check. I know it's confusing, but that's why I'm here to explain it right now. So not check means check. Good. Show or work in the space provided. Label each part. Use proper notation and box your final answers. Remember that on this section, your process is as important as your product. I should not type in all caps. Be sure to name each of your functions. You know how many people didn't name their functions? Quite a few. They lost the not check. They lost the notation check. In the future, though, you're going to lose a check every time. So notation, and what's the third one on the free response? Notation. No notation, no points. All right? Good. Write that in standard transformation form. Standard transformation form, remember, is A times G of B times X minus C, close, plus D. That is it. That's the form. Can't have a D in the back, can't have a X term second. It has to look like that. So here we go. F of X is equal to, the 3/4 is good. I got the natural log of, I'm going to commute the terms first. And then plus 7/5. Can we stop there? Is that standard transformation form? No. Now I named my function f, so good for me. I get 3/4 natural log. On the inside, I must factor out a -3, and that becomes an x minus 5/12. Now, how in the heck do you get 5/12? You divide out of 3, right? So it's and again, off to the side, it's like 5/4 divided by 3. which is the same as 3 over 1, right? And here comes the dog tricks, right? Stay, change, flip. And then you multiply straight across and you get 5/12. And notice I did that off to the side. Hey, there you go. Guess how many checks that was worth? 1. It was all or nothing. Had to be just like that. You could have written your LN without cursive. I also accepted that. Okay. Questions on that? All right. Find the simplified exact value of the y-intercept. Show the work that leads to your answer. How in the heck do I show someone that I'm finding the y-intercept for the function f of x? F of 0. That's all you really need. Really? It's that easy? Heck yeah. F of 0 equals 3/4 natural log of -3. When I plug it in, I get -5/12 plus 7/5. Now that would be if you plugged it into the standard transformation form. You could have plugged it back into the original as well. Is that simplified? No, because I can multiply those together. And so I get f of 0 equals 3/4 natural log, ooh, there you go, natural log of, what does that become? Positive 5/4 plus 7/5. So again, when you're finding the y-intercept, it's almost easier to plug it back in up here to the original one, because you'll see that that term goes to 0. And you could have left it as 7/5 plus that. That's considered simplified. And that's it. Can we do anything with that? Do we know what the natural log of 5/4 is? No. But I do know that the natural log of 5/4 is what type of number? It's positive, because the natural log of any number greater than 1, and 5/4 is greater than 1, is going to be a positive number. So is the y-intercept positive or negative? Positive number times a positive number is a positive number, plus a positive number is a positive number. So you didn't have to show this, but that is greater than 0. This is where you got the check right there. That was the second check. That's going to be helpful when I graph, because now I know my y-intercept is going to be above or below the x-axis. Above. And I do have one, yes? I do have a y-intercept. So if I do my graph and it opens up away from the y-axis, I'm like, criminy, something's wrong. And I go back and check it. All right, hey, we're at the sketching part, right? Sketch f of x showing the basic shape, which means you don't really have to show the dilations. The y-intercept and any and all asymptotes. I didn't want to tell you what type it was, but of course we know this one has a what type of asymptote? A vertical. Good. So let's go ahead and get our x and y axis. There's the y-axis. There's the x-axis. I'm going to go ahead and really quickly here do a scrap graph in yellow. Our parent function looks like that. Okay, has a x-intercept at 1, 0. So again, notice the natural log of anything greater than 1 is a positive number, and the natural log of anything between 0 and 1 is a negative number. What does the 3/4 do to the graph up here? Yeah, it's a vertical compression by a factor of 4/3. Now, I could have had you written that on the test, but I didn't. It's a vertical compression. So that just makes the graph a little bit squattier. Doesn't change its orientation or its where it lives. What does the negative in front of the 3 do? Kind of important? Yes, that reflects it across the y-axis. So now it opens that way to the left of the vertical asymptote. What does the 3 do in front of the x? Horizontal compression by a factor of 1/3. Does that change the shape or the orientation? Well, it changes the shape, right? Makes it a little bit steeper, essentially, when you compress it, but it still is decreasing to the left, so we don't really show that. Now the important one. We pick it up and move it right 5/12 and up 7/5. Now the up 7/5 we don't really show, but the right 5/12 is kind of important. So here we go. In festive blue, we have a vertical asymptote where? At 5/12. Because it was at 0, we moved everything to the right 5/12. So here we go. And now I know it crosses in positive land. And that was all you needed for the third check. I was looking for, did you have a vertical asymptote at 5/12? Did it open to the left? And did you cross in positive land? Those 3 things. That's all you needed. Now, if you had the wrong natural log graph, but it was still a natural log graph, some people graphed e to the x, some people graphed the natural log graph, and they also put a horizontal asymptote up here. Does the natural log have a horizontal asymptote? No, this thing does go to infinity, as you'll see when we get to the last part. Okay, so there is no horizontal asymptote. If you had an exponential function, or log function, sorry, and you answered the questions correctly based upon that, based upon having a positive y-intercept as well, you could have gotten credit after this. So that's when I said okay per or okay whatever. Find the domain. Well, the domain is what? Everything to the left of 512. So here's where your notation came in. Some people use the d sub f that I gave you, which is fine. It would be the set of all x then, such that x is strictly less than 5/12. And that was the, what check would that be, the fourth check? Some people went ahead and did interval notation. That would be everything from negative infinity up to 5/12 non-inclusive. Some people gave both, that or that. Do you ever want to do that on a free response? No, because if one of them's right and the other one's wrong, you don't get bonus points if it's right. You only lose points if one of them's wrong. So don't volunteer more information. Pick your favorite notation and go with it. All right, and then R sub f, what's the range? All real numbers. So some people reuse that. Hello. Thank you. I will send him. Or you could do this. You could say negative infinity to infinity. Some people did that. Or you can even fancy it up a little bit, right? The people who eat Grey Poupon, would we use x's or y's for the range? Y's. The set of all y's such that y is an element of the set of real numbers. Either one of those would get you the fifth check. All right, questions on that? All right. By the way, up here on the domain, again, I can give you credit for your domain based upon your graph. But you can always do what we did back on the multiple choice. Do we know how to find the domain now of a log function algebraically? Yeah. I know that the argument has to end up being what when I take the log of it to work? Greater than 0. So if you go 5/4 then is greater than 3x. This is another way I told y'all early to avoid flipping the negative. You can bring the x across, divide both sides by 3, and you get 5/12. And now the alligator is eating the 5/12. So when you flip it around, it still eats the 5/12. And there's another way to confirm the domain that you can compare to your graph. All right, we have 5 minutes left on this pep rally schedule, so we will proceed then. Find the equation of any and all asymptotes. Be sure to label which type they are. We have a what type? Vertical asymptote. So I would have accepted VA at x equals 5/12. That was the sixth check. VA at x equals 5/12. I did allow you to use the at symbol. Okay. If you said horizontal asymptote, you're out. If you said vertical asymptote at 5/12, you're out. If you said vertical asymptote at y equals 5/12, oh, you're out. Because the vertical line is what? X equals. Yeah. Now, what is the limit as x goes to negative infinity? If you hop on the graph, start heading out to the left, where are your y values going? They're going up forever and ever and ever and ever. So the correct answer, or the preferred answer, would have been infinity. But when you say the limit's infinity, does the limit exist? No, so guess what also works? D and E. So hopefully you've learned, when in doubt, D and E for limits, but hopefully don't ever be in doubt. Now, based upon your graph, I did give you credit if you had the right limit. Now, the notation, if you had the right notation all the way through, you earned the 8th and final check. So there were 16 checks total. The test on Monday, if you have to retest, it's going to be, again, eerily similar to this. You might be in shock. You might have to freak out a little bit before you start because it's going to be so similar, you can't believe it. Yes, but once you calm down, hopefully you can master it, make 100 on it. Of course, if you don't know how to do it, if I went too fast here, what can you do? I'm going to drop this video into the shared folder, and you can watch it all weekend long. That's a lot of popcorn you'd be eating, okay? If you ate popcorn while you watch these videos, okay? Ty, they want you as soon as possible, I guess. So sorry I hung on to that too long.
I did the graph wrong, but I got this answer correct.